Welcome back to the channel. This is the Earth Science Classroom. This video is on atmospheric science and meteorology, and we're looking at atmospheric pressure, how this is formed in the troposphere and how this pressure can change and adapt the atmospheric conditions and the weather. This is the Earth Science Classroom. As you see from this diagram, you have temperature and air molecules that are linked with atmospheric pressure. Now we're looking at the troposphere, which is that lowest layer of the atmosphere, which extends from the surface up to around 15 to 25 kilometers in altitude, which is based on latitude. Towards the equator, it is much higher. Towards the higher latitudes, the Arctic, Antarctic, it is much lower. But the troposphere is the area of focus with the highest air pressure, air molecules, and our concentration of the temperature. Now, gravity is the force of attraction that is keeping the air molecules pulled down towards the surface, thus creating general atmospheric pressure, or 1 atmosphere, which is around 14.6 pounds per square inch of pressure, just caused by gravity pulling down on the air molecules that have mass down towards the surface. So 99% of all the air pressure and air molecules is within the troposphere and stratosphere of our atmosphere, between the surface and around 45 to 50 kilometers in altitude. So the temperature is going to dictate the air pressure and how the air molecules react to said temperature or thermal energy being added or removed from the air molecules. So the absorption of thermal radiation heat is going to have a reaction which would change the atmospheric pressure along the surface of the Earth. That could be the surface of the landmass, the continent, or it could be the surface of the ocean. Either way, this is our focus in the troposphere and how air pressure is affected and basically controlled by the temperature and how the air molecules react to that temperature. Atmospheric pressure is a combination and has a relationship with both the temperature of the atmosphere and the air molecules within the atmosphere and how they behave and react when you change the temperature either to get warmer or colder, and that would have a direct effect on the atmospheric pressure in that given area. And we measure atmospheric pressure in millibars, or MB, or inches of mercury, which is INHG, or in atmospheres, which 1 atmosphere is the generic average, exerting 14.6 psi at sea level on average. And then we also have pascals, which is PA. So the different types of measuring atmospheric pressure can vary. However, I usually use millibars in my classroom just as that standard unit of measurement. Gravity exerts a force of attraction on the air molecules in the troposphere. So that creates a more consistent pressure of the air molecules pushing down onto the surface of the Earth, be it the land or the ocean. This gravitational pull exerted on the air molecules is equivalent to around 14.6 pounds per square inch, or psi, which is 1 atmosphere. Now, when we look into the addition of temperature or thermal energy into the system, which is concurrently working with gravity, you get the change in atmospheric pressure beyond just gravity and the force of exertion on the air molecules on the surface. If there is additional thermal energy applied to the air molecules in a certain area of the air called an air parcel, that air parcel would experience lifting because of a change of volume and change of density, and it's going to rise up. It's going to rise up, it's going to lower the pressure that has been exerted on the surface, and this would constitute lower pressure than 1013, which is the average millibars. And this rise in air parcel away from the surface would exert less pressure on the surface, and this would be equivalent to any number lower than 1013 millibars, or 29.91 inches of mercury. That would be lower pressure. Now, if there is less thermal energy added to the air parcel and it becomes denser with a smaller volume and higher density, and colder with less heat added that would exert a higher than average pressure on the surface, which is above 1013 millibars or above 29.91 inches of mercury. So you get this fluctuation in pressure beyond just what gravity does to the air molecules at the surface. And the addition or subtraction or removal of heat or thermal energy is going to produce a reaction in the air molecules which will create or have a product of the change in temperature, either lower pressure or higher pressure between the pivot or the average of 1013 millibars or 29.91 inches of mercury. So atmospheric pressure behaves as a dynamic system within the atmosphere, fluctuating the air pressure between high and low around the 1013 millibar point or mark or average, and this changes with time and also with location based on the factors discussed earlier. The factors which govern this dynamic system of air pressure in the troposphere is really controlled by solar radiation, and from that main factor you get the difference in latitude with concentration of solar radiation and heating of the atmosphere through conduction from the surface. You get elevation changes which will change the temperature of the surface, and also the humidity, the amount of moisture and water vapor in the air through evaporation, which will lower the air density because the water vapor is less dense than air molecules, both oxygen and nitrogen, and therefore more chance of rising the air through less density. So the main factor really is the solar radiation, and this is why the atmospheric pressure in the troposphere around the surface of the Earth is constantly in motion, rising and sinking, increasing, decreasing around that 1013 millibar average, and creating these atmospheric patterns of high and low pressure, different weather systems, different wind patterns, and this changes over time and also in different locations, so spatially and temporally. This is why it is an amazing dynamic system. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth science, please check out my channel.